This is the screencast for section 3.5, example 2, simple harmonic motion. Harmonic means going back and forth, so sines and cosines. We're going to study the motion of a weight on a spring. In this case, a weight hanging from a spring, in this figure, is stretched 5 units beyond its resting position and released at time t equals 0 to bob up and down. Its position at any later time t is this. Now I want you to understand what the position of this spring means. It is not the position of the weight. It is the position of the spring, because look how the weight gets higher, but the graph gets lower on y equals 5 cosine of t. What's happening is the weight on the spring is causing the spring to be 5 units longer than its resting position, so the position of the spring is 5 units longer. Then resting, then 5 units shorter. So we're talking about the length of the spring, but they're calling it position. So what are its velocity and acceleration at time t? So at time t gives you a clue that you're not really finding a value, you're finding a function of t. It might turn out to be a value by the time you take enough derivatives, but we'll see. So let's study the velocity, which is the derivative of position. And I have a coefficient times the cosine of t, so I can take the coefficient and leave that out in front, and then just multiply by the derivative of cosine of t. So I can take the coefficient and leave that out in front, and then just multiply by the derivative of cosine of t. So that's going to be 5 times negative sine of t, which is negative 5 sine t. So that's the velocity at time t. The acceleration is going to be the second derivative of position, or the first derivative of velocity. And again, we have, if we're taking the derivative velocity, a coefficient out in front, and then I can just multiply by the derivative of sine of t. So I get negative 5 times cosine of t. The now try problem number 11 says that a weight hanging from a spring, see this figure again, bobs up and down with position s. S is in meters, t is in seconds. What are its velocity and acceleration at time t? And I know we can dive right into here and find the derivatives, no problem. But let's try and understand this position, because it's now a sine curve instead of a cosine curve, which means at time t equals 0, this spring is going to be at its resting length. Then at pi over 2, the curve hits a maximum, so the spring is at its longest length. Then back at pi, the spring is resting again. Then it's at its shortest length, negative 5, at 3 pi over 2. Alright, so now that we understand what's happening to the spring's position, let's find its velocity and acceleration. The derivative of position is the velocity. Again, I can leave 5 out in front, take the derivative of sine of t, and I get 5 cosine of t. Then if I take the derivative of velocity, I get acceleration. So I can leave 5 out in front again because it's a coefficient, and then multiply by the derivative of cosine of t. Derivative of cosine is negative sine, so I'll have a resulting negative 5 sine of t.